All right, behavior of gases. We're going to talk about gas laws and properties of gases. They can be modeled using math. So it depends on volume of your gas, and that is expressed in liters. And then we have temperature of your gas, and that's going to be in Kelvin. Everything needs to be in Kelvin. You learned how to do that in the last unit. Okay, pressure is in ATMs or atmospheres. All right, so volume, temperature, and pressure. We're going to make calculations with those. All right, volume of a gas. Let's think about this. We learned this earlier. In a smaller container, molecules have less room to move around, and they hit the sides of the container more often, which causes what? An increase in pressure. Okay, so as volume decreases, pressure increases. So let's think of a syringe. All right, I'm going to abort here. Hold on. And let's look at this. Okay, so let's think about a syringe. Okay, here's my syringe, and there's gas in there, right? I'm going to pull gas in there. And then what happens when I push down? I'm decreasing the volume. What's happening to the pressure? Pressure's going up. Okay, so that is a great example of gas pressure versus volume. Okay, let's get back to our PowerPoint here. Okay. All right, so here is the quantitative relationship between pressure, temperature, and volume of a constant number of gas particles in a container. We call this Boyle's law. So at constant temperature, as the volume of a container decreases, the pressure in the container will increase. So we're going to represent that with arrows. As volume goes down, pressure goes up. But we can reverse that too. As volume goes up, pressure goes down. All right, and let's look at that. So here we see in the big square, we've got big volume, low pressure. But if we squeeze that box down to a smaller volume, then the pressure increases. So what kind of relationship is that? Let's look at that. And this also means as temperature is constant. So this means as pressure goes up, volume goes down, pressure and volume are indirectly related. Remember that, indirectly. Directly is when volume goes up, pressure goes up. That would be a direct relationship, but that's not what's happening. It's an indirect. As one goes up, one goes down. This is called Boyle's law. Here's Robert Boyle. Okay. All right. So another good example of this is a bicycle pump. Okay. So think about that's a closed container, and as the volume of air is trapped in the pump is reduced, if the volume of air trapped in the pump is reduced, its pressure goes up and air is forced into the tire. Okay, so great example of Boyle's law. Now let's do this practice problem together. All right. Let's get to here. Okay, so here's our practice problem, and this is how we're going to do all our Boyle's laws problems. All right. If we have 4 liters of methane gas at a pressure of 1.5 times 10 to the third, and let's just take that out of scientific notation for you. Okay, 3. So that means I'm going to move my decimal 3 places, 1, 2, 3, to the right. So that's 1,500 millimeters mercury. What will the pressure of the gas be if we decrease the volume to 2.5? So what do we know? We have 2 volumes, because what did we say we measure volume in? Go back up here. Volume is measured in liters. Okay? And then pressure, we learned before, can be ATMs, millimeters mercury, torr. There are several different units we're going to use. Okay, so let's pick these out. This law says initial pressure times initial volume equals final pressure times final volume. So our initial pressure was what? 1,500 millimeters mercury. Okay, and my initial volume was 4.0 liters. What will the pressure of the gas be if we decrease the volume to 2.5 liters? Okay, so we have two volumes, one pressure. What do we not know? What will the pressure be if we decrease the volume? So this is our unknown here. So every time you do one of these, you're going to write it out. Pressure 1 times volume 1 equals pressure 2 times volume 2. And you're going to plug your numbers into your formula every time. So we got 1,500 millimeters mercury times our volume 1, which is 4.0 liters, equals pressure 2, don't know, I'm going to call him X, or you can just put P2 there, times volume 2, which is 2.5 liters, right? And we're ready to calculate. What do we do when we do one of these calculations? I need to get X alone, so I need to solve for X. So I've got to get rid of this 2.5. So to get rid of the 2.5 liters, I'm going to divide both sides by 2.5 liters. These will cancel, so X equals 1,500 times 4 divided by 2.5. So let's put that in our calculator. So we got, oops, scoochie over here, 1,500 times 4, enter, divided by 2.5, control enter, so 2,400 P2 equals 2,400 what? Liters cancel, and I'll be left with what? Millimeters mercury. Okay, so there's my answer.